Welcome. Today we're diving into the Feynman Learning Technique, a powerful method for mastering any subject. Named after Nobel Prize-winning physicist Richard Feynman, this approach is all about understanding, not just memorizing. Feynman was famous for making complex ideas simple, and his technique helps learners do the same. Instead of passively reading or highlighting, you actively engage with ideas, organize your thoughts, and explain concepts in your own words. This method is popular among students, teachers, and professionals because it reveals what you truly know and what you need to work on. Let's explore how this technique can transform your learning experience. Richard Feynman was known as the great explainer for his talent in breaking down difficult scientific concepts into simple language. While he didn't formally invent the technique, his study habits inspired what we now call the Feynman technique. Feynman believed that many people only have an illusion of understanding. They can repeat definitions, but can't truly explain them. For him, real understanding meant reconstructing ideas from scratch and explaining them clearly. Educators later distilled his habits into a 4-step process that anyone can use to learn any topic more deeply. The heart of the Feynman technique is a simple but profound idea. If you can't explain something simply, you don't understand it well enough. This principle pushes you to move beyond memorization. You might think you know a topic until you try to explain it to someone else. The act of explanation forces you to organize your thoughts, clarify confusing points, and spot gaps in your knowledge. This turns learning from a passive activity into an active process, where you build true understanding step by step. First step in the Feynman technique is to pick a topic you want to learn. This could be anything, from cell division in biology to the causes of World War I. Start by studying your resources, textbooks, articles, videos, or notes. The goal here isn't mastery but to get a basic understanding. For example, if you're learning about photosynthesis, you might note that plants use sunlight to make food. Once you have this overview, you're ready to move on to the next step. Now try to explain the concept in simple language as if you're teaching someone with no background in the subject. Imagine you're talking to a child. Avoid jargon and focus on clarity. For example, instead of saying, photosynthesis is a biochemical process, you might say, plants make their own food using sunlight. Writing your explanation helps you be precise and clear. This step is the heart of the technique and often reveals whether you truly understand the material. As you try to explain the topic, you'll likely stumble on parts you can't clarify. Maybe you're unsure why a process works or what causes a certain outcome. These are your knowledge gaps. Instead of ignoring them, use these gaps as a guide for further study. Go back to your resources and find the answers. This targeted approach helps you focus your efforts where they're needed most, turning confusion into a roadmap for deeper learning. After filling in your knowledge gaps, revise your explanation. Make it accurate, clear, and concise. Use analogies if they help, like saying a computer processor is the brain of the computer. Repeat the process as needed until you can explain the concept confidently and coherently. This cycle of refining your explanation ensures that your understanding is both deep and durable. The Feynman technique is effective because it's rooted in principles from cognitive psychology. It's an active learning method. You generate explanations instead of just reading. It uses retrieval practice, which strengthens memory by recalling information from your mind. It also encourages metacognition, or thinking about your own thinking, helping you judge what you know and what you don't. Finally, it promotes elaboration by connecting new ideas to what you already know, making information easier to remember and use. The Feynman technique can be used by anyone: students, teachers, researchers, and professionals. School students can use it to prepare for exams, university students to master complex theories, and teachers to check student understanding. Researchers use it to clarify their ideas for presentations and papers. In the workplace, it helps professionals learn new technologies or procedures. The technique promotes deep understanding, identifies knowledge gaps, improves memory, and develops communication skills. Its flexibility makes it valuable for any subject or field. While the Feynman technique is powerful, it's not perfect for every situation. It takes time and effort, and some topics may lose important details if oversimplified. It also works best when you're motivated to find and fix your knowledge gaps. For rote memorization like vocabulary, you might need other methods too. Many experts suggest combining the Feynman technique with strategies like spaced repetition, retrieval practice, and dual coding for even better results. In summary, the Feynman learning technique is a simple yet powerful way to master any topic. By focusing on clear explanation, identifying and filling knowledge gaps, and refining your understanding, you move beyond memorization to true comprehension. Supported by research, this method helps you remember more, communicate better, and gain confidence in your knowledge. Ultimately, learning isn't just about collecting facts, it's about transforming information into real understanding. When you can explain something simply, you know you've truly learned it.